Welcome back to another video in the channel. So today I'll be looking at another inequality. So given that a, b, c are positive real numbers such that a plus b plus c equals to 1, prove that 1 over ab plus 2c squared plus 2c plus 1 over bc plus 2a squared plus 2a plus 1 over ac plus 2b squared plus 2b is always larger or equals to 1 over ab plus bc plus ca. This problem is taken from the 2007 Turkey team selection test. They won 3 of 3, so it's presumably the hardest problem on that day. So before we move on, please don't forget to subscribe to the channel and like the video and comment if you like to. So as in the spirit of solving inequality problems or generally any Olympiad problem, we want to convert it to a simpler one. So in this case, we can multiply both sides by ab plus bc plus ca, and we have the sigma of ab plus bc plus ca over ab plus 2c squared plus 2c larger or equals to 1. So we're trying to prove this, and here I use the sigma notation, which denotes the cyclic sum of ABC, and for example, sigma A is equals to A plus B plus C, sigma AB is equals to AB plus BC plus AC. And I use sigma notation because it is much simpler and much convenient to express. So I think you should try to learn it and get used to it because it will appear a lot in our latest videos in our channel. So the expression is still pretty complicated, so we still want to convert. Below I'll introduce a technique which will help further simplify the problem. The technique I was talking about is homogeneous polynomials. So in case you haven't heard about it before, it is a polynomial made of sums of monomials of the same degree. So for example, x to the power 5 plus z to the power 5 plus 10x squared y cubed plus 19x squared y squared z, they all have a degree of 5, and it is a homogeneous polynomial of degree 5. So it is useful a technique in dealing with inequalities because it can help simplify the problem and use some unknown conditions that we have not yet seen before. So for example, we can apply homogeneity on ab plus 2c squared plus 2c given that a plus c equals to 1. So we will have ab plus 2c squared plus 2c times a plus b plus c because it is equals to 1, and we have 4c squared plus 2ac plus 2bc plus ab, and we can easily factorize this into 2c plus a times 2c plus b. So the denominator will become a product of two monomials, which is very useful because we can further do some cancelling factorizations, and we can convert it into a much simpler problem to prove. So therefore we'll have the problem we're trying to prove, sigma of ab plus bc plus ca over ab plus 2c squared plus 2c larger or equals to 1, and it will be equivalent to the sigma of ab plus bc plus ca over 2c plus a times 2c plus b larger or equals to 1, which we have stated in the previous slide. And so we can convert it into sigma of 2c plus a times b plus 2c plus b times a over 2c plus a times 2c plus b larger equals to 2. And the reason I did this, or the reason I thought of this idea, is that I want to further simplify the denominator. So I create 2c plus a, 2c plus b on the numerator, so we can cancel them out easily, and it actually works. So therefore we would have the sigma of b over 2c plus b plus a over 2c plus a larger or equals to 2. And we will have sigma of b 1 over 2c plus b plus 1 over 2a plus b larger equals to 2. And we simplify, we will have sigma of b a plus b plus c over 2c plus b times 2a plus b larger equals to 1. And since a plus b plus c is equals to 1, we can further simplify problems to sigma of b over 2c plus b times 2a plus b larger equals to sigma b. And we finally would have b over 2c plus b larger equals to a plus b. So finally we would have we only have to prove b over 2c plus b times 2a plus b is larger equals to 1. So if we can prove this, we can add all of the terms up, and we have sigma of b over 2c plus b times 2a plus b larger equals to a plus b plus c larger equals to 1, which is what we're trying to prove here. So We cancel the b's on both sides. We have 2c plus b times 2a plus b is more equals to 0. I mean 1. And applying a and gn on 2c plus b and 2a plus b is a typo here. And we would have 2c plus b times 2a plus b is more equals to 2c plus 2a plus 2b over 2 squared, which is equals to a plus b plus c squared equals to 1 squared equals to 1. Thus, the segment of b over 2c plus b times 2a plus b will be larger equals to the segment of b, which equals to 1, which proves our problem. So, I hope you enjoyed the video, and it is actually not that difficult if you have a solid fundamental in algebraic manipulations. So I strongly suggest you to look into some books such as problem solving tactics to raise your skills a little bit more. So I hope you enjoyed. See you next time.